When you really think about it, the entire green energy transition pretty much hinges on one single piece of technology, the battery. And for years, that same component has been the biggest bottleneck holding the whole EV revolution back. So today, we're going to look at what might just be the single biggest leap forward in energy tech we've seen this decade.
For all the amazing progress we've seen, there are still three fundamental problems that are a major roadblock for a lot of people when it comes to adopting EVs. First, you've got range anxiety, that nagging fear in the back of your mind that you'll run out of juice stranded far from a charger. Then there's the charge times. I mean, who wants to wait 40 minutes or even longer at a charging station? And finally, there's the fire risk. It's rare for sure, but it's a very real and frankly terrifying possibility. The thing is, all three of these issues, they all come from the exact same place.
Okay, so to really understand the solution, we first have to look at the culprit. And that culprit is hiding inside practically every single electric car on the road today, the traditional lithium-ion battery. And specifically, its flammable liquid heart.
The critical component we're talking about here is called the electrolyte. The easiest way to think about it is like a highway running through the middle of the battery. It's this chemical soup that lets all the tiny charged particles, the ions, flow back and forth between the two ends. That flow is what creates the electrical current that actually powers your car.
And this is where you can really see the core problem laid out, right next to the solution. Today's batteries use this heavy, bulky, and flammable liquid electrolyte. That liquid is the direct reason for the fire risk, and its chemical nature puts serious limits on what other materials you can even use in the battery. It's literally the source of all three big problems we mentioned.
So, this brings us to the breakthrough, the one the entire auto and energy industry is calling the holy grail of batteries, and that is the solid-state battery. The name really says it all. You're replacing that unstable liquid with a stable, much more powerful solid.
The solution is really a two-step revolution. It's beautifully simple in concept, but its impact is, well, it's just massive. First, you just get rid of that flammable liquid. You replace it with an ultra-thin, super stable layer of a solid material, like a ceramic. Second, and this is where the real magic happens, that solid structure lets you use a pure lithium metal anode for the very first time. That was something that was just chemically impossible and flat-out dangerous to do with a liquid.
So the first benefit is immediate, and it's super obvious. When you swap a flammable liquid for a non-flammable solid ceramic, well, you completely eliminate the root cause of battery fires. It just makes the entire battery pack fundamentally safer, right from the get-go.
But what happens next is the real game changer. That new lithium metal anode, it allows for a huge increase in what we call energy density. Basically, it lets you pack way more energy into the exact same amount of space, or even less space. This is the tech that's going to kill range anxiety for good.
And look, this isn't some pie-in-the-sky science fiction that's decades away. The data is telling us that we are standing right on the edge of a massive tipping point. After years of quiet work in labs, this technology is finally moving out of the research phase and onto the road.
Now, this transition has been building for more than a decade. It started with fundamental research in universities back in the 2010s. Then we saw successful lab prototypes in the early 2020s. And now we are entering the era of real-world deployment. The years 2025 and 2026 are pegged for the very first production and test vehicles to actually hit the streets.
And the results we're seeing are, they're just staggering. Test vehicles are already getting incredible range. Some are hitting over 900 miles. That's more than 1,400 kilometers on a single charge. To put that in perspective, you could drive from Los Angeles to San Francisco and back and still have range to spare. And what about that charging problem? Yeah, that's getting solved too. The leading companies in this space are consistently showing off fast charges, going from 10 to 80% in just 15 minutes. That's about how long it takes to stop, grab a coffee, and get back on the road. It completely changes the whole experience of owning an EV.
Just to really put the scale of this leap into perspective, your average EV today gets maybe 300 miles of range, right? Solid-state tech isn't just a little bit better. We're talking about a potential tripling of that range. This isn't an incremental update, it is a full-on generational jump.
This isn't just one company working away in a lab somewhere either. This is a global race. You've got players like QuantumScape showing off these incredibly high-performance prototypes. You have legacy giants like Toyota pushing for an aggressive 2026 production date. And then you have companies like Factorial who are working to get this tech integrated with multiple big automakers all at once.
But
And you knew there was a but, right? For all of this incredible progress, for all of this game-changing potential, there is one absolutely brutal challenge left. It is the final hurdle standing between these amazing lab results and this technology being in every car on the road.
And that challenge is manufacturing. It all comes down to that paper-thin ceramic layer. The problem is, how do you produce that layer by the tens of millions, perfectly flawless, every single time, at a speed and a cost that actually makes sense for the mass market? It's a microscopic engineering problem that has to be solved on a global scale.
Which leaves us with the critical multi-trillion-dollar question that the entire industry is racing to answer right now. Is this truly the technology that kicks off the next phase of the EV revolution for everybody, or is that manufacturing challenge just so immense that solid-state batteries will stay an expensive, high-end luxury for the foreseeable future? Honestly, the next 2 years are going to decide everything.